New Zealand Grapher has 3 graphs for time series. You'll find them under graph type and look for time series. There they are there. You'll need each of those 3 graphs for your report, plus the table you just discovered, plus that table. You always, for variable 1, have to have the date. It will not work if you put vice versa. So date is variable 1. I'm going to start with this one here, seasonal effects. You'll note that the raw data starts in 2008 and it goes to 2016. I believe that is 9 years if you include 2008 and 2016. So over in this graph, I should actually have 9 cropped years of data in this graph. And the scale on this graph is the same scale as the raw data scale in the one I'm about to show you. What this graph is an average of this graph, or an average of the 9 graphs in here. Notice the scale has changed, and a 0 quarter means that there is 0 seasonal effect. A -1 seasonal effect means it's, in this instance, 0.1 million litres below the trend. So you might like to call this line either the datum, or you might like to call it the trend line, because that's what it refers to, the trend line. So from the trend line, Q2 is 0.3 million litres below the trend, and Q3 is 0.4 million litres below the trend, and Q4 is 0.8 million litres above the trend. Can you remember these 4 numbers? 1, 3, 4, 8. 1, 3, 4, 8. If you look at this graph in the middle here, and you look at the first value, 1, according to the scale here, I'll use this shape here. This one is 1, -1. This point here, it's hard to see, is -0.3. This is -0.4, and the last one's +0.8. And it repeats. 1, 3, 4, 8. 1, 3, 4, 8. 1, 3, 4, 8. So that's that graph in the middle. It's just the seasonal component, or the average seasonal component, duplicated, in this case, 9 times. Second major component is the trend line, and that's your MM. Okay, like we were doing with Excel, moving mean. And I suspect that the moving mean has an order 4 because it's quarterly data. So it's just the trend without the seasonal pattern has been removed. We call that smoothing the data. The black line is this raw data here. So the black line is just the raw data. The green line is an addition of the seasonal pattern plus the trend. So if you add trend plus seasonal pattern, you'll get the green line. And the other term that I use for the green line is the model. So if I'm referring to the model, I'm referring to the trend plus the seasonal. Okay, and the last thing I want to point out is this graph here. It's called the residual graph. Residual just means what's left over. So those with quick minds will know that it's the difference between the model and the raw. If you look for the gaps up here, like there's a decent gap, there's a decent gap, you'll notice the biggest spikes on the residual are in line vertically. So a big gap, big spike. In fact, if you look for the biggest spike, maybe it's that one, maybe it's that one, you can go vertically up and find the biggest gap. There's a big gap, big spike. And the last thing I want to tell you about residuals are completely normal. You never have a perfect model because of nature. because there's a cyclone turning up this week. There's residuals. So what's unusual though is a residual that's more than 10% of the range of raw data. What do I mean by that? If you look at the range of raw data, look at the black, it goes from 0.42, or I'll start at the bottom. Where's the lowest black value there? It goes from 2.6 all the way up to 4.2. The range of raw data, I think, is 1. Help me out here. 1.6, right? The range of raw data is 1.6 million litres. 10% of 1.6 is 0.16. So that's what we do. We take 10% of the range of raw data, and any residual that's bigger than 10% of the range of raw data is actually our model's starting to get weak. I wouldn't be surprised if I saw 1 or 2. Oh, another thing that the computer does, which is nice, you might not be able to see it from where you're sitting, but if you look closely, it puts a bold line at 10% of the range of raw data. So that's actually at positive 0.16, that line there. And at negative 0.16, there's another bold line there. Okay, so whenever you have a spike that pops outside that corridor, there's an event, or there's a cyclone, an earthquake, or it's something to be aware of when it's bigger than 10% of the range of raw data. But this particular graph, I'm pretty confident that this is a good model because they're all within, pretty much within the 10% range. If you have a model that's got lots of spikes that go outside the corridor of 10%, the model's crap. Can you say that? I just did. The model's rubbish. And your predictions are therefore pretty rubbish as well. If you've got a bad model, bad predictions. So that's kind of like a test to see how good your predictions are.